All right, so yeah, welcome to the last session of the day. And we're going to talk a little bit about building serverless applications in Ruby using AWS Lambda. So a little bit about myself. A fun fact about me is I actually don't have the same job that I had when I submitted this talk. So for about almost 6 years, I was on the AWS SDK for Ruby team. And I'm actually now changing roles and working full-time at AWS Lambda, building out open source tools for serverless. So I still have love for Ruby. I've talked a lot about it, and I'll still be working with y'all. But my roles have changed a bit, but fortunately still relevant to what we're talking about today. You can find me on Twitter at AlexWWood, and I kind of rate how well my talk is doing by how much people are talking about it on Twitter. So if you're looking down at your screen, I'm just going to presume that you're talking all about what we're doing here, and I'm totally cool with it. All right, so what we're going to cover today is I'm going to do a brief overview of what AWS Lambda is and the ecosystem that we have around it for building things. We're going to talk about a number of open source tools that we own within AWS, such as the Sam CLI, the AWS SDK for Ruby, and the AWS Record library for DynamoDB. And we're going to do a demo of an application that's a hybrid of both web APIs and event-driven functions to kind of show the power of what we can do and kind of how much you can do with very little code and configuration. All right, so serverless is dead. I'm sorry that all of you came to a talk about serverless, but as it turns out, serverless is already dead. Now, this is actually a statement by Chris, our principal developer advocate, in a talk that he gave that was excellent. But the reason I say this is I've noticed that the term serverless itself tends to elicit very strong reactions from people. And there's a lot of focus on the hype, and I don't think hype about serverless is going to come and solve all your problems is the right approach. So I think that AWS Lambda is a different type of compute model. Like, it's very different than virtual machines, and it's very different than containers. And I think when you think about it as just a different compute model, it actually lets you focus less on the hype and more on the actual tangible benefits that it provides. So what does serverless actually mean? Let's try to give ourselves a useful definition. So it means no servers to provision or manage. You're not worrying anymore about how am I setting up my servers, how am I configuring them, how do I manage them. AWS Lambda as a compute model is a managed service. A lot of this is handled on your behalf. So it scales with usage. So it can scale up very quickly. Your account by default can handle 1,000 concurrent requests on AWS Lambda, and you can raise that limit much, much higher. But what's also interesting about scales with usage is it scales down to 0. So if you have something that is infrequently used or an application that has very bursty usage, AWS Lambda follows that demand curve that you have much closer than a lot of available alternatives. You're paying for value. So there's a lot of examples of customers that have actually moved over to using AWS Lambda, and by and large, they're saving a lot of money. Because it turns out when you're only paying for compute capacity that you actually use, your efficiency of your compute spending is improved significantly. And a lot of availability and fault tolerance is built in. So imagine when it comes to scaling, what happens if you have a very rapid spike in traffic and you're kind of waiting for new containers to spin up to manage that traffic, and you'll catch up, but you're going to be very slow or actually have an outage. And AWS Lambda can scale up effectively immediately to handle your scaling needs. Availability. What happens if an instance crashes? So today, your load balancer is going to be serving up a few 500 errors to your customers until it figures out, oh no, this server is actually down, take it out of service and replace it. With AWS Lambda, if a container fails, you get maybe one error surfaced to a user, and then you have a new container on the next request seamlessly without worrying about it. So production app development, as I think a lot of you know, is a complicated endeavor. There's a lot that goes into it. So like, what do we need to think about? So we have our code and tests, which there are a lot of talks about. We focus a lot on our code. I'm really excited about the type checking that we're getting, the type checking that we're not getting, and a lot of the other improvements that we've been hearing about from all the great sessions so far. And that's the stuff that's actually providing direct value. There's a lot of stuff that we're not talking about in as many sessions that are things we don't want to spend time on, but we have to provide a production-hardened application. Things like availability and fault tolerance. How do we handle load balancing? What's our story around scalability? What are the different types of auto-scaling solutions that I need to actually keep up with shifts in traffic efficiently? There's also things like patching your operating system. I mean, raise your hand if you've had to deal with operating system patching yourself. See a few hands go up. Leave your hands up if that's fun. Right. It's a thing that we have to do, but we feel like we don't want to spend time doing it. And a lot of this now can just be handled for you. AWS Lambda handles a lot of these things out of the box. We talked about how it's doing load balancing. It's going to distribute requests across all the containers you have available. It's going to scale for you. It's going to do a lot to handle server and container failures. It provides an interesting story around security isolation that helps significantly reduce the surface area of security threats that you need to deal with. And a lot of that operating system management as patching is help for you. Also, when we talk about things like user authentication and monitoring, AWS Lambda tightly integrates with other managed services that we have to help give a smooth story around user authentication and to give a smooth story around monitoring. So you have to do a little bit of configuration, but a lot less than you might have had to do before. So this is kind of the power and why we care about it. It also works for a number of use cases. Like, it's not just web applications. You have your backend services, but you also have live data processing through services like Kinesis, like take real-time streaming data and process it, scaling up to how much data you're actually receiving. There's policy engines. So imagine if you use instances today and you're happy, but you want to verify people are properly tagging resources, or no one's going to spin up a production instance that's open to the internet. You can make that happen automatically, triggered by lifecycle events, rather than figuring out how to wire up an API to do that. All right, but this is RubyKaigi. We want to talk about the open source, and we want to talk about the tools. So I should also mention that we're going to cover a number of tools that we actually own and maintain, but there's also a number of interesting tools out in the community. I think on day 3, you have a chance to hear about Ruby on Jets. There's also the serverless framework, and there's even tools to try to bring Ruby on Rails itself onto Lambda, like Lambda. So this is not a full ecosystem, but these are kind of like the base building blocks that we're starting from when we want to do serverless Ruby. All right, so this is my new team. The sort of base infrastructure management tool that we provide to help you out is called the AWS Sam CLI, or Serverless Application Manager. And this gives you tools to generate new serverless projects, to build them in a way that is idiomatic for serverless, and then deploy these applications. It provides tools for developing and testing these functions locally, so you don't only have to deploy to be able to use it. So we have tools like local API gateway, hot reloading, so you can code and then see interactively, kind of like a Rails server, how your behavior changes. And you can find that on GitHub at AWS Sam CLI in AWS AWS Labs. So real quick, I just want to do a demo here. So here's what it takes to actually make a serverless project that works. We're going to init a new project with the Ruby 2.5 runtime. I'm going to make sure that I'm using the right RBM version. So right now we support Ruby 2.5, so any patch version of Ruby 2.5 you're going to be able to successfully build. And what we actually get here is a fully generated application. This is a hello world example. We're going to go into a much more fun example here in a minute. But we have tools like Sam build. So in AWS Lambda, we generally vendor our gem dependencies with our code. We can do this in layers, or we can do this with the code artifact itself. And Sam build essentially just does that for you. And just because of conference Wi-Fi, I'm not going to pull down the local image again, but we can actually take an API here and run it locally. So this is just a simple hello world stub example application which produces text far too small to read on a conference projector. Or really just says what our IP is and gives a little hello world as a JSON hash. So this is running on my local machine. No, this is not going to take 580 milliseconds if you deploy it to actual Lambda, but we get a little bit of extra overhead running on a local container. But yeah, this allows you to develop and test your applications locally as well as deploy. All right. So there's also the AWS SDK for Ruby. So this is the project that I've been working on for myself and others for almost 6 years now. I will say right now that we support greater than or equal to 174 AWS services. I add the caveat because I'm pretty sure that it's more than that by now. So every time I make this slide, it's wrong. But it is at least 174 different services. It has built-in support for important things like pagination or waiters on state changes. So you launch an EC2 instance, you want to wait for it to actually come up. We have built-in tools to help do that. It has built-in helpful abstractions for Amazon S3, Amazon SQS, and more. And important to the AWS Lambda use case is the fact that the AWS SDK for Ruby is modularized. So you can include only the gems that you need for the services you actually use. And because the code is all now statically generated in V3, one, I think hopefully it's going to make the sorbet people happy that they can do better type checking on it. But two, it improves performance of loading and to some extent a runtime. We also remove auto load for thread safety. So version 3 of the SDK provides a lot of thread safety mechanisms, and you can also find that on GitHub. And finally, there's the AWS Record Gem. So an interesting side effect of the scaling properties of AWS Lambda is you have the potential to learn which of your dependencies can and cannot scale. Because AWS Lambda has very high and effective scaling properties. Sometimes if you have a dependency that can't scale, you're going to find that your performance is suffering because of that. So Amazon DynamoDB is a database that has very solid scaling properties, and now even with pay-per-request billing, it, like AWS Lambda, can scale down to 0, as well as scale up to very high usage. The AWS Record Gem itself has very similar patterns to the Active Record APIs. It's not exactly identical because AWS Record supports aggregate types, since DynamoDB has map, list, and set types that a relational database typically would do through denormalization of tables. And it also provides declarative table configuration and migrations to try to keep it as close to the AWS Record experience as we can, while staying true to the fact that it's a slightly different database paradigm. So let's also do a quick demo of that. Really quick on text size, can people in the back see this reasonably well? I'm going to try to make it a little bit bigger. So fairly reasonable declarative syntax here. When we include AWS Record, it's going to decorate with much of the same methods we would see working with other database libraries. You'll notice one small difference here right off the bat, which is that we also declare a lot of our attribute types. And the reason that we do this is that Amazon DynamoDB only stores in the table the types of attributes that are part of a key or a secondary index. So in theory, we could have, and this is actually a pattern that a lot of customers use, you could have multiple virtual tables that are all part of the same table. So maybe the metadata attribute in another context is a string, and that's totally valid and supported. So let's actually make this table exist. And if anyone has wishes of luck with the conference Wi-Fi, I do have a backup, but we're going to actually try to make a table here. One other pattern about our declarative migrations is we actually try to maintain dry principles. So you can imagine having a dev, test, and prod table that are all very differently configured, but the attributes and code behavior are going to be the same. So table config not being built into the table allows us to have dry principles around this. All right. Let's see how long it takes to migrate. It should take about 10 or 15 seconds for the table to be up and online. I'm hoping. So while this migrates, I'll just point out we're going to do a little bit of a demo of like a couple item operations, and we're going to get to the fun stuff. Okay, conference Wi-Fi is, quick round of applause for the conference Wi-Fi, staying up. All right, so let's get a bit of an example here. I'm going to add a method to this class. So this is a fairly common pattern for just abstracting things out. So if we have a UUID, we want it to be randomly generated. Pass along the body, pass along the metadata. Okay, so we've got that, and let's actually create an example here. Okay, so I just pulled out the UUID to demonstrate that we could then go and actually fetch our item from the table. And we get all those properties there. Now, an interesting thing, raise your hand if you've used Active Record extensively. Okay, so we got a few hands. One interesting property of it is in most use cases, it actually uses item references to determine whether or not an item is dirty. So, we just pulled something from the database, and therefore this is a clean object. But one thing that's interesting is if you support aggregate types, you have to support mutation of those types. We're not going to be doing a new map object reference every time we change something. So we take our metadata, and we say, for example, today is Thursday. And I remember that this is a hash with a key. You have to mess exactly one thing up, at least with a live demo, or it's not really a live demo. But we can see here that now it recognizes that our item is dirty, and we can save the changes, and they're reflected. Anyways, the idea that I'm trying to express here is we have useful tools to help use different managed services that make your life of developing production quality apps easier. But we also came here to see pictures of cute puppies. So let's get into a live demo. Now, I'm just going to explain briefly what this application is actually doing. So we have a serverless website that is actually using Sinatra. So we essentially just write Sinatra code. It's very similar to an introductory blog post that shows you pictures of dogs and allows you to rate them on a scale of 1 to 10. Of course, the minimum acceptable rating is a 10. And allows you to upload new pictures of dogs, which I'm going to encourage you to do after I demo this. But there's an interesting trick. I only want you to be able to upload pictures of dogs. So when you upload a picture, it doesn't go up on the website right away. We have a little bit of post-processing. And what we're doing is we have another Lambda function that the trigger is a new object has been created in my S3 bucket. And that will automatically call Lambda. And what I do for those new objects is I say, hey, Amazon Recognition, an image recognition service, is this actually a dog? Be about 90% confident. I think I've found exactly one picture that's fooled it. And if it's not a dog, delete it. I don't want it. Don't put it on the site. And if there is a dog, then put it in the table, and it's going to display and be something you're able to write. And I will say, there's a few moving parts in here, but I've never really spent less time on DevOps than I have when I'm actually defining this. And you can see the web application components. This is fairly straightforward. This is a database, a web server, routing, and a CDN. And our event-driven components are fairly easy to reason about. We understand that a new object is uploaded. I perform a delayed job, although in practice this happens pretty quickly, definitely less than half a second. And then we write if it's compatible. We can also add a hook where if something is deleted from S3, we don't want to have dead links on our website. Maybe we did a cleanup of all dogs that are beyond a certain amount of time on the website. And we can just say, if something's deleted from the underlying CDN, delete it from the page. And we can make that an automatic triggered function. So we don't have to deal with the glue work of how do I detect a state has changed? How do I trigger something? How do I follow up on it? It just happens automatically. OK, somebody's probably just saying, show me the demo. I'm tired of this. So this is a picture of a dog. This is Katsu. He used to be in my team area, and we miss him very much. He's in another team area now. And he's a solid 14 out of 10. Let's add a new dog. I'm going to go ahead and throw out there while I'm uploading this. This application has a vulnerability of I validate that you can change the HTML. You're not going to rate a dog less than 10. I'm not letting it happen. I kind of failed to deal with a maximum rating. So, have at it. So now we've got a new dog, and I can't say no to that face. That's a 13 out of 10 at minimum. But I'm feeling a little mischievous, and I'm a little sad that I'm missing Aaron Patterson's talk. So I'm going to upload a picture of Corby Puff. Conference Wi-Fi is going to cooperate. Not there. It's a delayed job, maybe. Nope. Nope, sorry, no Gorby Puff on this website, only dogs. So while I wrap up, I encourage you all to try this for yourself. So you can go to link.alexwood.codes, rate dogs, and start rating dogs for yourself. I'll leave this up for just a second before we go and wrap it up. I will say for those watching this on video, I will not guarantee that this website is still going to be up by the time you watch it. But for everyone who's here trying it out, this also works on mobile. All right, so bringing it together. The benefits of serverless, why are we here? Because AWS Lambda as a compute model and the related managed services and tools we have around it handles a lot of the elasticity, scalability, high availability, security, and fault tolerance problems that you face when building production quality apps for you. It's going to do a lot of the heavy lifting so that you can focus on only the things that actually matter, the things that differentiate for you. So you're focusing more on code and you're shipping faster. So there's kind of been, over the years, a sort of ladder of spending more time on code and less time on everything else, and this is essentially the next step in that development evolution as I see it. There's a number of related talks that are out there that I encourage you to check out. So there is the Serverless is Dead talk by Chris Munns at the ATX Serverless Days. This provides an interesting coverage of a lot of what's an interesting fact about AWS Lambda I didn't cover is most of the traffic doesn't come from people using it for web applications. The vast majority of traffic comes from people using event triggers. So this talk covers a lot of the ways that people are using it for real. There's a talk on serverless architectural patterns, which covers a lot of interesting things you can build. There's a talk by Tim Bray on technology choices we use for modern applications within AWS. I will say in this talk, he's going to talk about Python and Go as being model AWS Lambda runtimes in his eyes. That talk was made before Ruby Lambda existed, and Ruby Lambda, I think, absolutely fits within that pantheon of runtimes that work, languages that work really well on AWS Lambda. And there's a lot of those same benefits. And there's also a talk on advanced design patterns in Amazon DynamoDB, and it's very much worth checking out. So thanks all for coming today, and I'm sure I'll see you all around at the rest of the conference and the after parties we have going on. Again, you can find our work on GitHub, and you can find me on the internets, both on Twitter and on the web. So thanks everyone for coming, and I think I'll take a few questions. And I should also note I have stickers up on the table here after we're done here. So I think we have time for a couple questions, and then we'll have more questions up here. All right. Thanks, everyone. I'll be hanging around here for a little bit, and thanks for coming.